start small, evaluate on that small data set. And from day one, you want to build observability and monitoring into the system, right? You don't want to ship your product and then be like, oh, like, how do I collect user feedback now? Because you want to make sure that your system is, you're constantly getting that user feedback and acting upon that. Again, it goes back to that trust thing, right? If you ship a solid thing based on your initial evaluation, but your system can't keep up with just context drift or just changing that long tail of user questions, then your users are going to lose trust in your system quickly. So evaluate on a small data set, even if you don't know, if you haven't shipped your product, and then design for collecting user feedback. I would say those are the two main things.
Welcome to Shift AI, where we bring together builders, researchers, and operators to unpack the challenges at the frontier of AI. I'm Javier Rincon from Productship, where I help build agentic AI systems with a focus on Evals. My guest co-host today is Adrián Tineo. Adrián, do you want to say hello?
Of course. Hey, glad to be here and good to see everybody.
And joining us today is Apoorva Joshi, Senior AI Developer Advocate at MongoDB. Hi, Apoorva.
Hi, everyone. I'm really excited to be here today. I got a little sneak peek of the topics that we are covering here today. So, yeah, really excited for this conversation. Thanks for having me.
Brilliant. So before we jump in, maybe could you tell us shortly about your current role at MongoDB? It sounds like a very exciting.
Sure, yeah. So I'm currently an AI-focused developer advocate. There's a lot of different terms for it. They call it technical evangelist. Personally, not my preferred term. It overlaps a little bit with forward deployed engineers, which is a more common term being used these days. But essentially, I talk to a lot of our customers, write a lot of technical content. I'm on a lot of podcasts at conferences. All of this really to help our customers and developer community build AI applications with MongoDB or just AI applications in general. And prior to joining MongoDB, say a year or so ago, I was a data scientist in the cybersecurity field for about 7 years. So, yeah, quite a switch for me in that sense.
What a switch, but nonetheless, very exciting time for you now.
Definitely.
So, excellent. So let's start with long context models. You shared with us, a new paper from 2025 from Cornell, the one that extends on Chrome's context network.
Yes.
And it really challenges the operational assumptions that teams make because the paper essentially says LLMs don't process long context reliably enough for production critical paths. So they tend to use lexical shortcuts, which is fine when the match is correct, but becomes a silent failure when it's a distractor. And further back the context sits, the faster reasoning quality collapses. So that has huge implications for anyone building real systems, especially pipelines, agents, or workflows that depend on consistent retrieval. So what do you think the paper reveals about the real limitations of long context models today? And what do you think these findings mean for teams who are actually shipping systems?
Sure, yeah. So the No Lima paper, I landed on that. I do like a paper club at work every month. So I thought that was a really interesting one for us to read. So I spent a lot of time reading that paper, then went on to read Context Routes. I kind of did it in a slightly different order. But I think it was really eye-opening for a few different reasons, right? One, I think it really calls out that the attention mechanism of LLMs itself is a limiting factor, where a few years ago, we all started with the assumption that attention is all you need. This paper kind of really challenges that assumption, right? And I'll touch on why that matters for this whole thing of context engineering and how people are building applications. But let me start with like the key findings first. So that attention one was a big one. Then also there's this concept of the claim context window. So whenever you see like model providers put out models claiming like our model supports 1 million context windows, you tend to take that as a developer. You take that as like a factual truth, right? It's like, oh wow, so cool, 1 million context. That means I can like stuff so many things into it. This should take care of like putting all, I can put long documents into this context now. Then if I'm using this reasoning LLM to build agents, then it should be able to effectively process all the reasoning traces, tool outcomes, tool calls, MCP, tool definition. There's so much ending up in the LLM's context. So if you as a developer are taking that as face value, that this LLM has a 1 million context, then it's pretty much setting you up for failure, because that's not the truth, right? There's like that claim context window, then there's an effective context window, which is a term that they introduced in that paper, which is essentially the number of tokens after which the performance of the model drops off beyond a certain threshold. And they've come up with a concept of what the base performance is. They have some metrics for that. And even the threshold is pretty generous. It's like 85% of the base performance, which is already a pretty significant dip when you're building on top of these models, right? And they found that the effective context window of a lot of LLMs that are claiming upwards of 200K tokens all the way to 1 million is actually, in fact, somewhere around 8K tokens, or sometimes even less than 1K, which is wild, right? And I'm just going to stop there, see if you have any questions, but that was really eye-opening to me, really.
It was really eye-opening, and I think the part I like the most about this paper and related works like that of Chroma with Context Rod is that it seems to me that now the industry is starting to mature. So we are looking at these systems no longer as a black box, but actually we're starting to characterize how they work and where they fail. And this
Right.
is very alien because these are new systems. We haven't worked with them before. So I think they are very good at fooling us in a sense that they look so amazing at first attempt. But then once we want to actually deploy something to production for real customer use cases, then we really care about performance. We really care about covering all cases, covering all bases. And these kinds of works really start to bring some maturity into the field and put some engineering back into the whole picture.
Yeah, exactly. And that's the thing, right? I feel like when I talk to developers, a lot of times they are focusing on systems other than the LLM, right? They're trying to get the retrieval down. They're like, should we use vector search? How do I improve my retrieval performance? Or like now we have this concept of context engineering where we are trying to like optimize the context window of LLMs. But a lot of times you don't question the LLM itself. You're like, if it's coming from Google DeepMind, if it's coming from OpenAI, we just assume that these are the best performing LLMs in the market right now, and you take it at face value that this LLM is going to support everything you want to build with it.
But not only that, but also if we think about understanding the nature of this attention mechanism, right? It's like this is not a problem that looks like it's going to go away in GPT-6. It's kind of
Oh yeah.
built in through the attention mechanism.
Yep.
So maybe it's something we need to learn about and characterize our systems around.
That's a really good point.
Touching on retrieval, let's connect it back to it because teams shipping real systems, retrieval is still the backbone. And something we see again and again is teams underestimate how much operational complexity comes from retrieval
Oh yeah.
choices. So vanilla RAG, hybrid RAG, graph RAG, agentic retrieval, each comes with a different reliability, guarantees latency costs, failure modes, and maintenance overhead. So as we're working closely with real production, something working with real production workloads at MongoDB, you've seen the trade-offs firsthand, I'm sure. So how should teams think about choosing between vanilla hybrid, agentic RAG, and others in 2025?
Yeah, I think based on a lot of my conversations, in whatever hybrid means, right, that seems to be the solution in most cases. I think we are, like 2 years ago, people are they would start with vector search, and for a lot of use cases, like something like vector search and just a little more would suffice. But at this point, you need a few different retrieval mechanisms in whatever system you're building. And this is because you're now having LLM applications typically dealing with a broad spectrum of queries, different user personas. So you kind of pretty much have to use different retrieval techniques because, like you said, right, all of them had different strengths, different failure modes, and things like that. A big one was code retrieval. So a lot of customers that I've lately been working with are coding agents or coding droids. They're called some providers are calling them droids these days. But those solutions, and there's this huge debate on whether these embedding based retrieval is the way to go for these solutions. A lot of them are moving to agentic retrieval, but which is very similar to agentic RAG, I think. But I think the main idea now is for agents to decide what to retrieve, right? And I think what we are finding even there is that just using grep or find doesn't suffice for some types of queries. Sure, if you have like a definite code base, if you have a small code base, maybe. But if you have a large code base, then actually doing the pre-processing of generating embeddings and maintaining like an embedding database is still worth it. So I think whatever problem you throw at these applications, I'm starting to realize that hybrid, whatever retrieval techniques you include in hybrid, that might change, but hybrid is seems to be the way to go. So to me, the architecture now is like you have a reasoning LLM, give it access to a few different types of retrieval tools, give it access to a grep or find tool, a vector search tool, graph-based tool, whatever retrieval tools you think are the most useful for your applications, and then let the LLM decide which tool to use for which queries.
Yeah, I think retrieval is obviously a key part in every AI system these days. And I really like the part you said about the agentic code, agent to retrieve code. And I think that matches our experience as well with financial documents that where the information is very nuanced, then an agent would basically be more effective by virtue of chewing on the problem longer.
Mm-hmm.
And I relate this to one comment which I heard from Jan LeCun. I think it was at Lex Friedman podcast, and now Jan is starting his own startup apparently. And he had this concept which is really eye-opening for me, which was like we have these systems, right? And you put the input tokens, and then you have some amount of compute, which is pretty much fixed, and then you get a token out. And then it looks like you have a fixed amount of compute, but not all problems require, I mean, fixed amount of compute per token, but not all problems are equally hard. So what do you do when you have a harder problem, when you need more tokens? It's kind of a proxy into getting the system to think for longer. And we have the thinking models, and now we have the agentic loops. And it's all just a way of keep chewing and keep generating tokens and kind of, structure the problem in a different way, planning, whatever, until you find the actual solution that matters, right? And I
Mm-hmm.
think that's what agentic is unlocking in a new degree. Also, in a way that engineers can act upon. Because again, it's not just the black box, it's not just thinking model. You put in a thinking budget and you cross your fingers and hope for the best. Now you have an agentic token, an agentic flow where you can intervene and you can have retrieval pieces and you can think about the embeddings and try to be an engineer in that space. Is this something you're seeing with folks that they're getting more involved into that process, or is it just one size fit all?
Um, I'm not seeing that many human in the loop kind of workflows, to be honest. Like I do see folks in more sensitive industries like healthcare, legal, thinking about human in the loop, but things like coding agents, people are just I'm not saying they're letting them fly on their own, but they're putting more work into helping the agents do things more autonomously rather than focusing on like introducing human in the loop in those workflows.
Right. And in the end, we got to find a way to know if we're making progress or not, right? Like which ties with one of the topics today, right, Javier, which is about evaluating workflows.
Yeah, absolutely. And you did mention before benchmarks, and now they publish different benchmarks that not pertain to reality. So maybe let's connect benchmarks to something also that's operational in sense of evals, because here's what we keep seeing with teams. So benchmarks say the model is great, as you mentioned it, people ship it. Then in production, you get workload specific failures, regressions after model updates, long context extractors, overconfident mistakes. So all issues that never showed up in the benchmarks. And all of this, of course, really leads to eroding the trust. So we're starting to think benchmarks show potential, but evals show the reality inside the system. So, benchmarks can look impressive, but the teams tell us that the performance often falls apart in real workload. So, why are benchmarks not enough? And where do you see evals becoming essential to keep systems reliable?
I really, first of all, I really liked how you said, drew that distinction between benchmarks and evals, where evals really show the reality of things. I really liked how you put it. Um, so here's my take on benchmarks, right? I think the first single glaring flaw with benchmarks like MTEB, MMLU, is that they're public. The minute it's public, it means that anyone can train and overfit on these data sets and make their models look better than they are. And we know that this happens. So recently I saw this other benchmark, which is kind of an improvement on MTEB called RTEB, which is like the retrieval text embedding benchmark. I think they try to evaluate on a combination of public and private data sets, trying to kind of rectify that trust problem a little bit, right? Because you have that private element to it. Maybe it's not maybe, it's harder to overfit on those benchmarks. And then the other thing with benchmarks, right, is the neatness issue. And I think this kind of gets into like this can get philosophical very quick because, and I understand why researchers need to do this, right? But human behavior is just so hard to predict. And if our future is helping agents or basically AI to help us with some of the human tasks that we do on a day-to-day basis, then we really need a way to evaluate them on how are these models performing in the real world, right? But and a lot of the menial tasks that we do on a daily basis are complex, multimodal, non-deterministic sequence of things, but there's no real way to measure that. So I think that's really why benchmarks fall apart, because you can have like the most solid software coding benchmark, the best puzzle solving, problem solving, math problem solving benchmark, but like that's really not does not translate to what we use these models for, what we want to use these models for moving forward. And this is an open problem right now. These kind of tasks and the metrics to measure these tasks are really hard to come up with, which is why I think we don't see as many benchmarks really outlining like these set of real world jobs or tasks. But I was really impressed to see the GDP eval benchmark from OpenAI recently, or even ARC AGI, which is basically an unsolved bounty for how close a model is getting to AGI, or like trying to reward that kind of behavior with models. So yeah, those have been really refreshing for me to see because they measure the general usefulness and intelligence of the models.
Yeah, definitely benchmarks are a hot topic. And what we can find sometimes is that there is not enough rigor, like scientific rigor, in the way they're being used. And sometimes there's like a small print. So even Llama 4, right? I think it was well known that they were kind of faking the benchmarks, and then they would give a very high number, but then you read the small print and it's like, okay, it was a success at 25 attempts, something like that. I forgot what it was,
Yeah.
but it's like, okay, it's clear that now benchmarks are used as a presentation card for the model benefits, and it gets gamed, and there's an incentive for frontier labs to do good, and because you can't release a model that doesn't do better than the previous one, so you always got to keep climbing the ladder.
Yeah.
Some of those benchmarks are saturating at the same time. They're not being representative of what people really care about. So it's also giving a false impression, similar to the long context dream,
Yeah.
that is giving a false impression to folks. And then it's on one side, we look at the news, it looks like we live in the future already. And then you go yourself, try something out, and it's like, wait a minute, this is not working. Like there is this test I did the other day, and we've got GPT-5, which arguably won a gold medal, whatever. And then I'm putting into an agentic loop, and I'm doing a hello world, and it's stamping over the format of the output. And it's like, wait a second, is this the real the gold medal winning model?
Yeah.
So obviously there are many nuances around how these models operate, and benchmarks don't quite capture the whole picture.
Mm-hmm.
And now as an industry, we got to figure out what do we do now? How do we actually characterizing what matters? And a lot of the problems like you were describing is like open-ended and nuanced and multimodal, and it gets complicated fast. And that's, I think, where evals tell a truer story, but also requires that everybody works on them themselves to make them
Hmm.
fit their actual use case, and that actually requires some probably education around it. So how do you find that folks are using eval in the field?
They're not. I think that's kind of the unfortunate and scary reality of shipping AI systems right now. Right now, there's just a race to ship quickly and ship the cool thing first, right? You want to beat your competitors to the market. So
Mhm.
evals doesn't come up as often as I'd like it to. Um, eh, it usually comes up when people actually run into an issue, right? It's like, oh,
Mhm.
even when I talk to a lot of our customers, it's like I'm not seeing the performance. My system is performing poorly. I'm like, tell me more. And then they're like, what more do you want me to tell you? And then I'm like, well, I thought you'd measured it. You must have some metrics for it. Have you, if you're building a RAG system, then is retrieval the issue? Is generation the issue? Like, do you know where the gaps are? And usually the answer is no. But I think that's the thing. Like, that's the reality of shipping AI right now, and I just wish more people would take eval seriously. So I don't have a good answer for. I mean, I have answers for how to go about evals because that was pretty much non-negotiable when I was shipping AI applications pre-Gen AI. But right now, that's what I'm seeing.
I think we should find a new name in the same way that we have vibe coding. We should have vibe evals, which is like my system is not working properly, but I can tell exactly why. So it's kind
Right.
of a vibe
Yeah.
that I'm getting from my system. So, but we gotta keep making progress and building these systems for real. So that brings us maybe to our next topic around how to actually put everything together, right, Javier?
Absolutely. And actually, before even jumping to that topic, you did say something that's, I feel, reminiscent of a few years ago, maybe with the rise of analytics
Hmm.
in, the rise of Web 2.0, where people were just shipping and there was no real interest in trying to understand activation and retention, right? And then a lot of those companies, of course, ended up having real challenges in terms of retaining users. And then there was a real big push towards understanding the user, right? What is happening in our product? And then a lot of analytic systems came out, whether it was Mixpanel and Amplitude. And me, from my history, we were in the middle of that, doing implementation. It feels very, like a parallel, situation
It
that's
does,
happening.
doesn't
But
it?
it really, right? And I think trying to take away some of the learnings that we had from there, you mentioned something about, people don't use them unless they really need them, unless something fails, right? It feels like we're in that early adopter era of evals, right? Where
100%.
people are, right, where they're excited, they have of shipping. There's a misunderstanding of capability. I think also a big challenge is that there is a barrier between usage and capability, right? So when there's a gap in seeing how users are how AI is responding to users, and each of those experiences is different. I think the fog of war is even bigger. So you mentioned how you guys tackle evals, and how you maybe you could give us a short snapshot of how you kind of work around them, and how you guys do that.
Yeah, I think my strategy so far has been like start small, right? Start with a small data set. Like, and there's few. I guess I'm gonna say two things. Like before you ship a product, you don't know what kind of things your users are gonna ask, but you kind of have, you should have a sense for what you're designing for. So you, as the designer of the system, should kind of have a good sense of, okay, I think these are the type of questions I'm solving for. These are the type of things I think my users are gonna ask from my application. So start with a small set, even if it's like 50 set of questions. Start with that. Let's say we are going to try and evaluate the system on those 50 queries. Then come up with you know what the business outcome of this is, work backwards from that to come up with 2 or 3 metrics for uh, how to measure the performance of your system. And I think measure that performance on those 50 queries. If you're designing, again, a RAG system, then measure each component of the system separately, like measure the retrieval component, the generation component, and the system as a whole. If you're designing tools, then if you're designing an agent, then you want maybe unit tests for each tool to make sure that each tool is doing what you want it to. And then the overall performance of the system, maybe LLM as a judge. I know I really like Galileo. I think their way of measuring agent performance is really good. I'm blanking on the exact names of the eval metrics that they use, but just go check those out. I think those are pretty good. So that's kind of my approach to it. We start small, evaluate on that small data set, and from day one you want to build like observability and monitoring into the system, right? You don't want to ship your product and then be like, oh, like how do I collect user feedback now? Because you want to make sure that your system you're constantly getting that user feedback and acting upon that. Again, it goes back to that trust thing, right? Like if you ship a solid thing based on your initial evaluation, but your system can't keep up with just context drift or like just changing that long tail of user questions, then your users are going to lose trust in your system quickly. So yeah, evaluate on a small data set, even if you don't know, if you haven't shipped your product, and then design for collecting user feedback. I would say those are like the 2 main things.
Fully agree. And exactly how we implement metrics too on web analytics. So that's great to see that correlation there. Brilliant. And jumping on to our last question, so I want to touch a little bit on agentic flows. So we've talked about long context, retrieval strategies, evals. So let's bring it to something very practical. So how AI applications should actually be designed today. So there's a huge wave of excitement around agents, reasoning loops, tool use, planning, multi-step workflows. But something we see in real work is agentic systems look powerful in demos, but they multiply operational complexity. So suddenly you're dealing with state management, partial failures, cascading errors, tool timeouts, retries, dead ends, and the need for evals across entire flows, not just model calls. So the big question becomes, what does an operationally sound agent stack actually look like? So where do agents actually make sense? And what does a reliable AI architecture look like?
That's a good one. And I read Anthropic's Building Effective Agents blog from a few months ago, and I still think a lot of those principles apply, right? Like and I read about it. I did my own research and came up with my own understanding for it and I largely agree with what they had there. So I would say design for the system that you need, not for the system that you think you need or the internet is telling you need, right? Like my first thing is like if you have a deterministic thing that you need your system to do, then don't have an LLM do it. Try to offload as much as you can from the LLM. So if you have something that you can do using rules, heuristics, a small model, just good old code, then do that. Like just because an LLM can do it doesn't mean you have to like have it do it. So use agents or LLM for their strengths. Like if there's things like classification, sentiment analysis, do you need an LLM? No, you don't need it. If you want to do things like building social copy or generating a bunch of free-flowing natural language content, then LLMs are a good fit for that. And then again, if your flows have like a deterministic sequence of events to follow, then do you need an LLM to determine that sequence? You probably don't. You can code that, put that in your code. You can use tools like Airflow, tools that we've been using previously, right? Like I think we should not, the knowledge that we've built from building ML applications, software applications for the past so many years still applies. Like we want to take those learnings and incorporate those into this new wave of systems that we are building. It doesn't reset what we've done up until now. So yeah, agents are great for open-ended tasks, but if you have any deterministic components, then you want to build again, going back to hybrid, right? You want a combination of deterministic and LLM-based workflows. Also, multi-agents is interesting. I haven't quite seen a system that truly needs multi-agent workflows. I still think there's a lot you can get a lot done using an LLM and a solid set of tools. Multi-agent, again, I think just complicates things even more. It's honestly a debugging nightmare. So if you don't have a good use case for multi-agent, then again, don't use it.
Yeah. I really like the way you put that not everything needs to be solved with an LLM. But maybe just a quick follow-up question is that a lot of teams get a lot of pressure because they have an AI mandate that they need to roll out AI no matter how. So what would you tell those teams?
Go back to evals, right? If you can design two systems, and this is something I had to do on my first job not too long ago. I was the new cool kid data scientist who was supposed to like replace a system with a machine learning based model, and there were like researchers who had built a heuristics based tool, and I was like, okay, how do I make a case for it? Like talking is clearly not helping it. So I'm like, I'm going to evaluate the model that I'm training against this heuristics based systems, and then once I could show my team that the numbers show the numbers, then that was really it. I didn't really have to do much else. So go back to evals.
Great answer. Perfect. So wrapping up here, let's jump into the rapid fire. Three short questions. Don't be scared. They're
All right.
very easygoing.
Those are always
but
the
yeah,
hard
just-
ones for me, but let's do it.
I think you'll find them okay, I think. So for example, what's your top best practice teams should follow to be successful with an AI implementation?
Use LLMs wisely.
Very nice. What's one mistake you see AI teams make again and again?
Not evaluating their AI applications.
Very good. That seems to be a good trend here. And lastly, if an agent could replace one task for you or one workflow for you tomorrow, which would it be? Whether it's personal or business?
If it could cook for me, that'd be great.
Oh, so we're waiting for that physical AI to get here.
Yes, definitely. Because that's really the thing, right? Like the things that you do on a day-to-day are very much physical things. Like apart from even your 9 to 5 is a physical thing for a lot of people.
Well, we'll be excited to welcome that also.
Yeah.
I'll join you and I'll put myself in the wait list too. Well, we're at the end of today's episode, so I want to thank you again, Apoorva, for joining us today. A lot of insights that we learned, and you guys, go check out MongoDB. They have a lot of great resources to keep getting better. Everything AI. Thank you so much, Adrian, for joining us today with great questions. And yeah, thanks everybody for joining us in Shipped AI. See you in the next edition and keep shipping.
Thank you so much. This was great. Thank you.
Thank you.
Bye, guys.